Yes. Next topic is periodic table. Periodic properties of the elements. Periodic properties of the elements. In the last class we discussed about the very important concept, that is electronegativity. Electronegativity. What do you mean by electronegativity? Here group number 13, 14 and 15, 16 and 17 is a group of the elements. 17 group of the elements. I will consider these are the electronegative elements. Among these group of the elements are most electronegative. Most electronegative. Trend in the modern periodic table. Trend in the periodic table. Trend in the periodic table. Trend in the periodic table. In the last class we discussed about along the period, along the periodic table and down the group. Down the group. This is increases and down the group it decreases. This is the trend in the modern periodic table. Trend in the modern periodic table. Now what about the important significance of the electronegativity? And what are the applications of this electronegativity? By knowing the value of the electronegativity is what can we do? Now, very important one, by knowing the electronegativity, and what are the various factors that electronegativity that depends on? It depends upon the first factor, factors affecting the electronegativity. First one is atomic size and effective nuclear charge. Factors depends on electronegativity. Factors depends on the electronegativity. Factors depends on the electronegativity. There are so many factors that depends on the electronegativity. First factor is atomic size. How do you predict the electronegativity of the elements? The first factor is the atomic size. See, along the period, atomic size decreases. Along the period, atomic size decreases. Atomic size decreases. Atomic size decreases, and hence electronegativity. Electronegativity increases. With atoms of the smaller elements of the smaller atomic size, smaller is the atomic size, smaller is the atomic size, smaller is the atomic size, higher is the electronegativity. Higher is the electronegativity. Here is the electronegativity. Smaller is the atomic size, higher is the electronegativity. Therefore, atomic size is inversely proportional to electronegativity. Electronegativity is inversely proportional to the atomic size. Electronegativity is inversely proportional to the atomic size. That is why among fluorine, bromine and iodine, atomic size fluorine is smaller than chlorine, smaller than bromine, smaller than iodine. Therefore, electronegativity of fluorine greater than chlorine, greater than bromine, greater than iodine. Now, with respect to this is down the group. There is a carbon, nitrogen, oxygen, fluorine. When you compare all this, 14th group, 15th group, 16th group and 17th group, there is atomic size that gradually decreases. Therefore, here the fluorine is the smaller atomic size compared to the oxygen atom. Oxygen is the smaller atomic size compared to this nitrogen atom. Nitrogen is smaller atomic size compared to the carbon atom. Here also, atomic size is gradually, that is decreasing order. Atomic size is decreasing order. Atomic size decreasing order. Atomic size decreasing order. Atomic size decreasing order. Electronegativity increasing order. Electronegativity increasing order. Electronegativity increasing order. Therefore, electronegativity of carbon is smaller than that of the nitrogen, that is smaller than that of the oxygen, that is smaller than that of the fluorine. Electronegativity is increasing order. Because atomic size, C greater than N greater than O greater than F. Therefore, atomic size and electronegativity both are reciprocal to each other. Smaller is the electronegativity, higher will be the atomic size, or higher is the electronegativity, smaller will be the atomic size. That is why the alkali metals with higher atomic size, they possess very least electronegative values and they are more electropositive values. Is it clear? The first one is atomic size. This is very important for entrance exam point of view. These are called the hints. In entrance exam, they will give this type of the terms. You should know the atomic size. When you know the atomic size, then only we can predict the value of the electronegativity or the mass, which one of the following is more electronegative, which one of the following is less electronegative, or arrange the following in the increasing order of the electronegativity, or arrange the following in the decreasing order of the electronegativity, like that they will ask. Is it clear? Fine. The second one is second one, effective nuclear charge. Effective nuclear charge. That is denoted by means of Z effect. Z effect is given by means of Z minus sigma. What is Z? That is equal to nuclear charge. That is given by means of nuclear charge minus shielding effect. shielding effect. Nuclear charge minus shielding effect. Shielding effect in the sense screening effect also. In the last class we discussed about the shielding effect, the sigma. Shielding effect is represented by means of the sigma. Now in any one of the atom, you know the structure of an atom. In the structure of an atom, in the nucleus the whole positive charge is concentrated, and next to the nucleus in various shells and subshells the electrons are distributed. The higher energy level electron is considered as a valence electron. Therefore, the electrons which are present in the higher energy level, they always exerts repulsive forces with that of the inner atomic orbital or inner shell electrons, and positive charge, since positive charge is concentrated in the nuclear zone, and hence the attractive force towards that of the nucleus. But due to the inner shell electrons or inner atomic orbital electrons, the attractive force of the valence electrons or higher energy level electrons towards that of the nucleus is decreases. Is it clear? That is the reason why, due to the presence of this screen, the effective nuclear charge, the attractive force, that decreases. This phenomena is called as a shielding effect or screening effect. Now various factors that is said by means of the inner atomic orbital electrons, as the number of the shells that increases, the shielding effect it also increases, the screening effect also increases. As the number of the inner atomic orbital electrons or inner shell electrons that increases, therefore they exerts more repulsive forces, and hence the shielding effect that increases. Then if the electron is very close to that of the nucleus, therefore the shielding effect is very less, because no hindrance is there between that of the nuclear charge and that of the outer atomic orbital electrons. For example, in case of the hydrogen, whereas the hydrogen electron is very close to the nucleus, therefore it does not exert any repulsive force that of the inner atomic orbital electrons. Whereas for the single electrons the shielding effect is different. Whereas if suppose one of the shell that occupied by means of the ns and np atomic orbitals, ns and np atomic orbitals, for ns atomic orbitals is different, ns and np atomic orbitals is different, n minus 1 atomic orbitals are different, n minus 2 atomic orbitals, the values are entirely different. Therefore, when you calculate the z value, that z effective nuclear charge can be determined by means of using that of the shielding effect values. I will give the shielding effect values for the single electrons and that of the two s atomic orbital electrons and ns and np atomic orbital electrons, the values are different. For that of the single electrons, the values would be different. Therefore, electronegativity is directly proportional to electronegativity is directly proportional to Z effect. Higher the value of the Z effect, higher is the electronegativity. When does the higher value of this should be lower? Whenever the shielding effect is minimum, then the Z effect is maximum, because Z effect is obtained by means of Z minus sigma. Therefore, whenever the sigma value is minimum, Z effect is maximum, and hence the electronegativity is maximum. Usually for the non-metals, the electronegativity is maximum, in the sense this should be the minimum values. Now the next one is electronegativity that's based upon the hybridization. This is a new concept. Hybridization state of an atom. Hybridization state of an atom. Now in hybridization state of an atom, you know about the hydrocarbons, especially hydrocarbons. We come across three types of the hybridization: sp3 hybridization, sp2 hybridization, and sp hybridization. In sp3 hybridization, that is involved in the, what do you mean by hybridization first? Hybridization first. It is a new concept for you. You know that in the chemical bond formation, what do you mean by the chemical bond? It is one type of the attractive force between the two atoms, which force the two atoms together in the molecule of the substance, or it is often considered as a repulsive force also. Therefore, attractive force or the repulsive force which holds the two atoms or more than two atoms together in the molecule of the substance is called as a chemical bond. There are different types of the chemical bonds are there that you know. Ionic bond, covalent bond, coordinate bond, metallic bond, and also the van der Waals forces of attraction. That is one type of the chemical bond is there. Physical force of the attractions are there. Now in the covalent bond formation, ionic bond formation that you know they studied in the previous classes. Whereas the ionic bond is formed by means of complete transfer of the valence electrons from most electropositive element to the most electronegative element. Therefore, most electropositive element acquires positive charge by giving off the electron, and most electronegative that acquires negative charge due to the consumption of the electron. Therefore, across one side we have positive charge, across another side we have negative charge. Between these two, we have electrostatic force of attraction or Coulombic force of attraction. That phenomena is called as a ionic bond formation. Usually ionic bond compounds are crystalline in structure, they are soluble in water, and the solutions are their good electrolytes. Okay, and they possess high melting point and high boiling points. Whenever the covalent chemical bond is formed, very important, most of the organic molecules they possess the covalent chemical bond. What do you mean by the covalent chemical bond? A chemical bond which is formed by the sharing of the electrons between two atoms, where each atom contributes only one electron for the chemical bond formation, is called covalent chemical bond. During this formation, we need two electrons. In any covalent chemical bond formation, we need two electrons. One electron is shared by means of the first atom, another electron is shared by means of the second atom. Then the chemical bond that is formed between the two atoms is called as a covalent chemical bond. For example, this is the A and this is a B. A shares one electron and B shares the one electron. Therefore, the covalent chemical bond is represented by means of the putting these two dots. That is referred as a covalent chemical bond. For example, in case of the HCl formation or HF formation or HBr formation or HI formation, whatever it may be, and HI formation. See, in this bond, covalent chemical bond, here also covalent chemical bond, here also covalent chemical bond, here also covalent chemical bond. Whenever the electronegative difference is very large, then we can have the ionic bond formation. Whenever the electronegative difference is small or very near to each other, then we can expect the covalent chemical bond formation. Therefore, here these two electrons are migrated more toward that of the fluorine atom. Here the covalent bonding electrons are migrates toward the far away from that of the chlorine atom. Here the covalent chemical bonds are still far away from that of the bromine atom. Here the covalent chemical, that is the sharing of the electrons that occurs still far away from that of the iodine atom. Reason, the fluorine is most electronegative element, therefore it has ability to withdraw the shared electrons towards it, whereas it captures the shared electron towards it. Whereas the chlorine is less electronegative compared to the fluorine atom. That is why the sharing of the shared electrons that is not very close to that of the chlorine atom, because chlorine is less electronegative compared to that of the fluorine atom. Whereas in case of the bromine is still less electronegative compared to the fluorine and chlorine. Therefore, the shared electrons are still far away from that of the bromine atom. Therefore, in case of the iodine atom, whereas the shared electrons are still far away from, therefore, see the location of the shared electrons. Shared electrons are very close to the fluorine atom and they make some distance from that of the chlorine atom, more distance from that of the bromine atom, maximum distance from that of the iodine atom. That previously we discussed, that all depends upon the atomic size. Smaller is the atomic size, higher the electronegativity. Therefore, the electronegativity is inversely proportional to the atomic size that we already discussed. Here, in case of the sharing of the electrons, now the concept is called as a hybridization. Whereas that, you know that the S atomic orbital is spherical shaped atomic orbital, P atomic orbital is dumbbell shaped atomic orbital, where the shapes are different, energy level associated atomic orbitals are also different. Now, during the chemical bond formation, they are introducing the new concept that is called hybridization. Hybridization is the phenomena in which the atomic orbitals, which are different in shapes and the difference in energy levels, we merged with each other in order to obtain the new energy level atomic orbitals, mixing up of the half-filled atomic orbitals. Therefore, the process of the mixing up of the half-filled atomic orbitals, which are different in energy levels and different in shapes, in order to obtain the new equivalent atomic orbitals which have difference in energy levels, so that is the same in energy levels and same in shape. Not same in shape, but the appropriate shape here. Now, for example, assume that you have 4 can paints. Among this, 1 can red paint and 3 can white paint. Now, suppose 4 different walls are here. Now, I wish to paint this 4 different walls. But now I have 1 can red paint and 3 can white paint. Can I paint this whole, that wall is by means of red color, and can I by means of white color and white color? No. What we are doing, we are mixing the red, 1 can red paint and 3 can white paint. Now it gives 4 can pink paint, where the percentage of the red is 25%, white percentage is 70%. This is example for hybridization. Now suppose mixing up of the 1 can red paint and 3 can white paint to give the 4 can pink paint is called hybridization. That is, hybridization is the mixing. Now suppose 3 walls are there. We have 1 can red paint and 2 can white paint. Now what we are doing, suppose this wall and this wall and this wall you have to paint, but we have only 3 can. Out of 3 can, 1 can is red color paint and 2 can is white paint. What we are doing, we are mixing, we are taking one big container and we are pouring 1 can red paint, ENE. This is unsaturated hydrocarbon. Unsaturated hydrocarbon, whereas structurally this is like this. See, it has an unsaturated molecule, double bond bearing molecule. The type of the hybridization here is sp2, because the doubly bonded molecules always they exhibit sp2, and here this is sp2. This implies that here the S character is 25%, P character is 70%. Here S character is 33%, 33.3%, P character is 66.7%. P character 66.7%. This implies ethene carbon is more electronegative than ethane carbon, more electronegative. En means electronegative than, more electronegative than ethane carbon. Ethane carbon is more electronegative than ethane carbon. This implies that the doubly bonded carbon is more electronegative than single bonded carbon atom. And one more thing that you have to remember, in case of the ethine molecules, ethine means acetylene or ethane molecule. Ethine means ethine, acetylene, CH triple bond CH. Here CH. Here this is sp hybrid. This one is sp hybrid. This is also sp hybrid. And between these two we have sp overlapping. Between these two we have sp to sp2 overlapping. Here S character is 50%. And P character is also 50%. S character is 50% and P character is 50%. This implies that ethane carbon is more electronegative than Ethyne carbon is more electronegative than ethene carbon. That is why, suppose you have the formula in entrance exam, they may give the one of the molecule like this. One of the molecule. Suppose this is a CH3, CH2, CH, double bond CH, single bond CH2, and C triple bond CH, and single bond CH3, suppose. Now this is molecule that possess all the type of the covalent chemical bonds, all the types of the covalent chemical bonds. Here see this star carbon atom. Here this is sp hybrid carbon atom. This is sp hybrid carbon atom. This is sp3 hybrid carbon atom. This is sp3 hybrid carbon atom. This is sp2 hybrid carbon atom. This is sp2 hybrid carbon atom. This is sp3 hybrid carbon atom. This is sp3 hybrid carbon atom. That all depends upon the nature of the covalent chemical bond, whether it is a saturated or unsaturated bearing double bond or unsaturated bearing triple bond. Preference in the order, therefore preference in the order, more electronegative carbon atom. In your entrance exam they will ask which one of the following carbon atom is more electronegative in nature. Therefore triple bond carbon atom is more electronegative in nature, in the sense it has ability to withdraw the shared electron towards it. For example, I will give CH, triple bond H, single bond C, triple bond C, single bond H. This carbon atom has ability to withdraw the electrons, therefore it occurs negative charge and it occurs positive charge. Therefore hydrogen, it always gives off in the form of the H plus ion. H plus ion donor, therefore H plus ion donors are called acids. Therefore acetylene hydrogen is acidic in nature. That is about the application. Acetylene hydrogen is acidic in nature. This is about the information that you got from electronegativity of the carbon atoms. Is it clear? You know that only acids are acidic in nature, like that of hydrochloric acid, sulfuric acid, nitric acid. These are acidic in nature. But acetylene hydrogen atom is acidic in nature because it has ability to give off the hydrogen. You know the one of general property of the acids. The acid that react with metals gives bubbles of hydrogen. Am I right? Yes, fine. Similarly, when acetylene gas is made to pass into the sodium metal, it gives the bubbles of hydrogen. Reason, acetylene hydrogen is acidic in nature. This is a very important application of the electronegativity values. Therefore, among ethane hydrogen, ethylene hydrogen, acetylene hydrogen, which hydrogen is acidic in nature? Acetylene hydrogen is acidic in nature. Reason, acetylene carbon is electronegative carbon. Therefore it has ability to withdraw the shared electron towards it. When it has ability to withdraw the shared electron towards it, then hydrogen is replaced as hydrogen ion. Therefore proton donor, proton generator. Therefore proton donors are called acids. Proton generators are called acids. Very important one. Ethane does react with sodium metal, or ethylene does react with sodium metal, or acetylene does react with sodium metal. Only acetylene react with sodium gives bubbles of hydrogen. In your entrance exam, they will give the question, which one of the following hydrocarbon gives bubbles of hydrogen with sodium metal? Whether ethane or ethene or ethine or none of the above. Ethine react with acetylene means ethine, Y-N-E, ethine hydrogen, terminal hydrogen. Not ethane, some of the molecules that contain so many hydrogen, but terminal position, suppose it is there. That is possibility only in case of the terminal hydrogen, terminal alkynes. In terminal means end, either first end or last end. If suppose it possesses the triple bond, those type of the alkynes are called as the terminal alkynes. Okay. I'll continue the next period. Thank you.